Assalamu alaikum. Today we will be solving two-sum problem. So basically we are given an array of integers, nums, and an integer target. We need to return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So this assumption simplifies the problem-solving process because you can focus on finding the single pair of numbers that satisfies the condition rather than considering multiple possibilities or handling error cases. Here, as we have an example, our array contains these numbers. The target is 9. The output would be 0 and 1 because when we add number at the index 0 plus the number at index 1, 2 plus 7 would be equal to target 9. Alright, we have other example here with array containing these numbers and target equal to 6. So here we know that 3 plus itself is equal to the target 6. But we need to use a different number. We can't use the same exact number more than once. And this is why our output is the index 1 and 2. 2 plus 4 equal the target 6. In this example, we can sum the 3 plus this different 3 because we will return different indices. The index this at the index 0 and this number at the index 1. So our approach, we have two approaches today. The first one is the brute force approach. The brute force refers to a straightforward and exhaustive approach to problem solving. It involves trying all possible solutions systematically until the correct one is found. So in this case, the brute force approach involves iterating through each element in the array and checking if there is another element in the array that when added to the current element equals to the target value. This process is repeated for all pairs of elements in the array until a valid pair is found. So once a pair is found, we need now to return the indices of the two numbers. So while the brute force approach guarantees finding a solution if one exists, it can be inefficient for larger problem sizes. For example, I'm gonna position my index and iterate through each element in the array to find a pair that adds up to the target. So first of all, we have these two indexes that correspond to numbers 3 and 2. We know that this is equal to 5 and this is not correct. This is not our target. So I'm gonna iterate our second indexes, and now we have 3 plus 4. This is equal to 7, which again not our target. So we're gonna iterate the first index right now, and now we have 2 plus 4 equals 6. Now the Dart code solution would be using 2 for loop and iterating through our array and check whether we have two numbers that equal to our targets and return them. If not, then we need to return an empty list. Now the other approach, the best one, is the hash map approach. With this, we're gonna create an empty hash map to store the elements and their indices. We need as well to iterate through each element in the array. After that, calculate the complement of the current element. And the complement means target minus the current element. After that, we need to check whether our complement exists in the hash map. If it exists, then we need to return at this time the indices of the current element and its complement from the hash map. If not, then we add the current element and its index to the hash map. This approach has a time complexity of big O n. So it's a linear time actually. Let's see this in a real example. We said that we need to create an empty hash map to store the elements and their indices. Now going through indices, we'll assume that the first number is I equal to 3. Now we know that the complement is equal to target minus the index. Target is 6 minus the index 3 equal to 3. Now the complement exists in the hash map, but the index associated is our earlier index. So this is not the good answer. Let's keep going. Now, if we choose to work with I equal to 2, the complement would be here number 4. Let's look for number 4 in a hash map. We can see that that's right. We do have number 4 stored in our hash map with the associated index, which is 2. So we want to return the index 1 and 2 because those indices adds up to 6, and that would be the good answer. So here is our LeetCode solution. We need first of all to create the empty hash map to store the elements. After that, iterate through each element using a for loop. After that, we calculate the complement of the current element. Then we check whether the complement exists in the hash map. If it exists, then we need to return indices of the current element and its complements from the hash map. If it doesn't exist, then we just need to add the current element and its index to the hash map, and that's it. Here the result of my submission on the LeetCode platform. Now talking about time and space complexities. See, you choose to work with the brute force approach. The time complexity would be O n square, and this is because we have nested loops where the outer loop iterates through each element in the array and the inner loop iterates through the remaining element to find a pair that adds up to the target. However, the space complexity is pretty good because it doesn't require any additional space proportional to the input size. It only used a constant amount of space to store variable for looping and comparison. Now, using the hash map approach, the time complexity would be linear. In the worst case, when all elements need to be inserted in the hash map. Same thing for the space complexity. It's also linear because in the hash map approach we use the hash map to store the elements and their indices. And in the worst case, we may need to store all the elements in the hash map, resulting in a space complexity of theta n. So you may see that the hash map approach is more efficient in terms of time complexity, as it reduces the time complexity from O n squared to O(n). However, it requires additional space to store the hash map, resulting in a space complexity of theta n. So this is all for today. Thank you for watching and enjoy the journey of knowledge by my explanation.